Hello guys, hello guys. This is Tushar. Today we'll discuss a very important topic, which is quadratic equation. This is the lecture 1 of quadratic equation. So before starting this topic, let me discuss about myself. That I am Tushar Kumar. I am now studying MSc in Mathematics and Computing at IIT Hyderabad, and I have more than 2 years of teaching experience. So let's start the discussion first. So before starting the topic, let me introduce first what type of topics we will discuss in this particular video. So first topic would be the polynomial expression. After that we will discuss about the degree of polynomials. Then we will discuss about the quadratic equation. After that we will discuss about the roots of an equation, then Sridhar Acharya's formula. And after that we will understand what are the relation between roots and coefficients. It can be sometimes says that sum and products of a quadratic equations. Then we will learn about the formula for discriminant, and then we will do some problems related to these concepts, or you can say related to the quadratic equations, which actually came sometimes from in JEE mains, sometimes in NTSC or KVPI and some other academics level, right? So we'll do some mathematics related to this particular topic. So let's start the discussion by showing you the first part, which is polynomial expression. So what is polynomial expression? So polynomial expression is an expression of the form Px, which is equals to an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus dot 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 up to a2 x to the power 2 plus a1 x to the power 1 plus a0. You can see the sequence, right? So first of all, so where all ai's, so what ai's means, here an minus 1, an minus 2, a2, a1 and a0 are the ai's. I am just writing down in a short form, and I have mentioned what I goes from. I goes from 0 to up to n, right? So what will happen actually? Suppose ai is there, right? And I goes to 0 to n, right? 0, 1 to up to n. So for I equals to 0, we will get a0, right? For I equals to 1, we will get a1. For I equals to 2, we will get a2, and up to for I equals to n, we will get an, right? So we will get all these ai's, right? an minus 1, an minus 2. So you can write down here as an minus 1, an minus 2. These are the real coefficients. What is coefficient? Coefficient means the part which is multiplied with the variable x to the power n, the part which is multiplied with x to the power n minus 1. Here an is nothing but the coefficient of x to the power n. An minus 1 is nothing but the coefficient of x to the power n minus 1. An minus 2 is nothing but the coefficient of x to the power n minus 2. Similarly, the part a2 is nothing but the coefficient of x to the power 2, and the part a1 is the coefficient of x to the power 1, and a0 is the constant term, or sometimes you can say the coefficient of x to the power 0, because you know, right, x to the power 0 is nothing but equals to 1. So we can write down here a0 as a0 x to the power 0, right? So all these coefficients are real. That is very important. It should not be complex, it should be a real, and then px is called a polynomial expression. So this particular expression may seems like a very difficult expression, but we will discuss some of the examples so that you will understand what a polynomial expression would look like in general. So first of all, a polynomial expression in general simply looks like that, and all the coefficients should be real. That is a very important part, right? So let me discuss some of the very important, some of the examples related to the polynomial expression. So here you can see that this is a expression, right? This is an expression, so there is no issue, right? So first of all, you can see that the part related to the part which is multiplied with x to the power 2 is 3, and definitely 3 is real. The part multiplied with x is minus 2, right? We can write down x as x to the power 1, so minus 2 is also real. 5, that the constant part, is also real. So here all the coefficients are real, right? All the coefficients are real. So since all the coefficients are real, so this is a polynomial expression, right? There is no issue. So let me discuss another example, which is x to the power 5 plus x to the power 4 minus 2x cube plus 3x square minus 2x plus 2. So here you can see that the term, that the constant term which multiplied with x to the power 5 is obviously 1, because there is no term, so I can say that 1 is multiplied with x to the power 5. Similarly, 1 is multiplied with x to the power 4, minus 2 is multiplied with x to the power 3, 3 is multiplied with x to the power 2, and minus 2 is multiplied with x, and the constant term is 2. So here all the coefficients are 1 comma 1 comma minus 2 comma 3 comma minus 2 comma 2. So here you can see all the coefficients are reals, not complex, right? So this is also a polynomial expression. So let me discuss another example, which is the third example. So here you can see that the coefficient of x to the power 3 is 5, so which is real, so definitely it will not face any kind of issue, right? So the part which is related to x to the power 2 is minus 2, so this is also real, so this there will be no issue. The part which multiplied with x is 4, which is also a real part, but here you can see that minus 6i means the constant part, right? The constant part of the expression is minus 6i, so this is not a real number, right? This is not a real number, and the definition says all the coefficients must be real. So since this is not a real number, this is a complex number, so this expression is not a polynomial expression, right? So this part is not a polynomial expression. Sometimes you can say the polynomial expression is a real polynomial expression, right? We are discussing about the real polynomial expression. We will discuss when you will be when you will study when you will study the undergraduate level, postgraduate level, then you will know about the complex polynomial expression. But currently for your academic purpose, we will discuss only about the real polynomial expression. That is why the coefficient terms must be real. It should not be a complex number. So I think the polynomial expression concept has already been cleared in your mind. So let me shift to the next slide, which is the degree of a polynomial. So since we have understand that what is a polynomial expression, right? Real polynomial expression. So now we will discuss about the degree of polynomial. So degree of polynomial definition says the degree of a polynomial is the highest power of the variable in a polynomial expression. First of all, you can see here that the polynomial is denoted as px, right? Here you can see the polynomial is denoted as px. It is not necessary that always the polynomial expression will always shows like px. It may be written as qx, it may be written as capital AX, it may be written as capital BX, anything, right? These are sometimes called the polynomial expression. It is the general denotation process, right? So here you can see that the degree of a polynomial means a polynomial expression is necessary, is the highest power of the variable. So from the previous slide you can see the variable is x, right? X is called the variable. Sometimes an expression is given to you with variable y, sometimes an expression is given to you as a variable z, right? So there is no necessary that you will get a polynomial expression in terms of x. You will get sometimes an expression related to related to the variable y, related to the variable z. So you will get different variables, but the main motto should be that the px or the py or the pz must be a polynomial expression, and after that the degree of a polynomial is the highest power of the variable, right? We have to check the highest power of the variable in a polynomial expression, right? And one thing I must be clear that degree of polynomial, right, always belongs to the natural number, you know, right? No, it is whole number, right? So what is whole number? 0, 1, 2, 3 dot dot dot. So degree may be 0, maybe 1, maybe 2, maybe 3, right? So from the previous slide we can say that these n minus 1, n minus 2 are actually goes from 0 to up to n, right? So it will varies. So let me discuss one thing, that so first example is given like 6x to the power 4 plus 2x to the power 3 plus 3. So here you can see that whether this is a polynomial expression or not. So first of all we have to check whether the expression is a polynomial expression or not. If it is a polynomial expression, then we will move to the second step, which is what will be the degree of the polynomial, right? So here you can see that the coefficient of x to the power 4 is 6, the coefficient of x to the power 3 is 2, and the constant term is 3. So all the coefficients are real. So sometimes student says that, sir, here you can see that the part related to x to the power 2 related to x is not there. So we can write down this particular expression as 6x to the power 4 plus 2x cube plus 0x square, right, plus 0x plus 3. So here you can see that these are also the part related to x square related to x. So here you can see 0 is also real, 0 is also real. So this is nothing but a real polynomial expression. So we have to take the maximum, because here you can see that the highest power. So here you can see the power of x is 4, here you can see the power of x is 3, here you can see the power of x is 2, power of x is 1, and power of x is 0. So we have to take the highest power, I mean the maximum of 4, 3, 2, 1, 0, right? So here you can see that the maximum of 4, 3, 2, 1, 0 is 4. So the degree will be 4. So let me discuss another example, which is suppose x cube minus x square plus 5i. Can you tell me what will be the degree of the expression? So first condition would be like we have to check whether this expression is a polynomial expression or not. So here you can see that the coefficient, that the constant term is 5i, which is not belongs to the real number, right? So since this is not a real number, so we cannot say this is a polynomial expression. This is not a polynomial expression. So we will not move to the second step, which is how to find the degree of a polynomial, right? So this is not a polynomial expression, so we should not find out the degree of the real polynomial expression. So let me discuss another example, which is x cube minus x square plus 5. So can you tell me what will be the degree of the expression? Here you can see that the degree of this part is 3, the degree of the power of this part is 3, the power of this part is 2, and the constant term is, obviously here you can see that the power of x to the power 0, right? So if we take the maximum, you will get the degree will be 3, right? So this polynomial expression has degree 3. So after that, let me discuss one thing before starting this particular topic, which is quadratic equation. So what is polynomial equation, right? Polynomial equation. Since you know what is polynomial expression, suppose a polynomial expression is denoted as px. If we equate this particular polynomial expression with a polynomial expression, if we equate this polynomial expression with a polynomial expression, then this particular function will called a polynomial equation. Or you can say, if we equate this particular polynomial expression with 0, because it will also it will also one of the polynomial equation of px, right? So you can understand that if a polynomial expression is given to you like x square x plus 5, and if we equate this part as suppose 5x plus 2, then this is a polynomial equation. Or you can equate with 5 only, you can equate with only 0, then this is also a polynomial equation. So if there will be any equate symbol, right, equation symbol, then it is called a polynomial equation. So what is quadratic equation? Quadratic equation says the quadratic equation are the polynomial equation. So first of all, quadratic equation is a polynomial equation of degree 2. So here is a foundation that we have to take as the degree 2 of the polynomial equation, right? We can't take degree 1, we can't take degree 0, we can't take degree 3, 4, 5, we have to take only degree 2, like x square plus 5x plus 2 equals to 0. So this has degree 2, definitely this will be a quadratic equation. So quadratic equation are the polynomial equation of degree 2 in on variable. That is very important. We can't take more than one variable like x and y, that will not happen. Here only we will get only one variable, right? Of type, here you can see fx equals to ax square plus bx plus c equals to 0. As you know about what is polynomial equation, so you can say that a, b, c are real numbers, right? Are belongs to real numbers. And another condition added to this particular concept is that part which is multiplied with x square, that the highest degree, highest term, highest power of x is not equals to 0. I mean that part a is not equals to 0. Sometimes students say, why sir, why? If a equals to 0 will be there, so what will happen? Basically, if a equals to 0 will be there, definitely that particular term will be vanished, right? Then we will get only bx plus c, which is equals to 0. Definitely it is not a quadratic equation, because the degree of this particular part will be only 1, right? So we have to take only degree 2. So that is necessary that the coefficient of x to the power 2 must be non-zero, right? So let us take some examples for which you will be understand what a quadratic equation would look like, right? This is, you can see that 3x square plus 2x minus 5 equals to 0, right? So here you can see that the coefficients are real and the degree of this expression is 2. So this is a quadratic equation, right? Quadratic equation. I am just writing in short like QE. Let me discuss another part, which is 5x square minus 2 equals to 0. So this is also a polynomial equation and the highest degree is 2. So this is also a quadratic equation. You can see this is also a quadratic equation and this is also a quadratic equation, right? Suppose if I will give you another example, x square minus I equals to 0. Can you tell me, is that a quadratic equation or not? Sir, first of all, we have to check what is polynomial equation, right? We have to check whether this equation is a polynomial equation or not. But here you can see that this part is a complex number. So definitely this is not a polynomial equation. So there is no need to check whether this particular expression is a quadratic equation or not. So this is not a quadratic equation, right? This is not a quadratic equation. So let us move to the next slide, which is called the roots of an equation. So what is roots of an equation? Suppose an equation is given to you which is px, it may be fx, it may be gx, it may be hx. It can be denoted like that. Suppose if fx is a equation equals to 0, a equation is given to you. So root of an equation is a constant term. Suppose, so let me discuss one thing very clearly, that root of an equation is always a constant term, right? So root of an equation is always a constant term, and that may be real number, that may be complex number, right? So that may be real number or that may be complex number, and that must be satisfied with this equation, right? Suppose if 2 is the root of this equation, then definitely instead of x, if we put 2, then f of 2 will be 0. Like this condition will be satisfied. Okay, so root of an equation is nothing but a constant term which may be real, may be complex, and it must be satisfies the equation, right? So that is all about the root of an equation. Let me discuss another example, which is suppose x plus 1 equals to 0. So this is the equation, there is no issue. Let me discuss one thing, that if we put x equals to minus 1, here you can see that the left hand side will be minus 1 plus 1 and it would be 0, and you can see that the right hand side are the same. So x equals to minus 1 satisfies this equation, right? And minus 1 is a real part, it may be complex, right? So this is minus 1 is a root of this equation, right? Okay. So what is relation between roots and degree? So basically relation between roots and degree is number of roots equals to number of degree. What does it mean? Suppose a polynomial equation f(x) equals to 0 is given to you, and you see that the degree of this polynomial expression I am write down as d of f(x), right? Or you can say that degree of f(x) will be suppose 5. Then you can say there are exactly 5 real or complex number exists. Complex number has a different kind of setup, that it will be a coupled pair, but you can generally say that there are 5 reals and complex numbers exist which satisfies this f(x), right? So suppose a quadratic equation is given to you, which is suppose x square minus 3x plus suppose 4 equals to 0. Then since this is a quadratic equation has degree 2, then you can say the roots of this particular equation are 2, right? There are 2 numbers in real or complex exist which satisfies this particular equation. So this is a relation between roots and degree. Okay, so what is Sridhar Acharya's formula? This is a very important formula which every aspirant should be settled in their mind, and I believe that you guys already studied about this particular topic, but we'll discuss soon later. Okay, so what is a quadratic equation? A quadratic equation would look like x square plus bx plus c equals to 0, right? Where a, b, c are real number and a not equals to 0, right? So what Sridhar Acharya did is, Sridhar Acharya is divided this equation by a, then it will become x square plus b by ax, right, plus c by a equals to 0. Since a is not equals to 0, so we can divide both sides. So after that we will trying to make this as a perfect square. In order to make the perfect square, we have to take like x square plus 2x and b by 2a. So here you can see that after cancelling these 2, we will get b by a into x, right? And additionally we add b by 2a whole square minus b by 2a whole square, and extra part is c by a, which I just write down here. So here you can see we can write down this particular equation as this equation, right? So from this particular part you can write down as x plus b by 2a whole square, right, minus it will be b square by 2a ka whole square plus c by a equals to 0. So what will be the value of x plus b by 2a ka whole square? It will be b square by 2a ka whole square minus c by a, right? So x plus b by 2a ka whole square will be equals to, I am just taking the LCM, right? So it will be b square minus 2 square means 4, a is there, so definitely we will get only a, c, right? So b square minus 4ac is on the numerator and the denominator will be 2a ka whole square, right? So if we take square root on the both side, we will get plus minus root under b square minus 4ac by 2a ka whole square. Then we will get plus minus root over of b square minus 4ac by 2a, right? So x plus b by 2a will be this part. So what will be the value of x? It will be minus b by 2a plus minus root under of b square minus 4ac by 2a, right? So you can write down as x equals to 2a minus b plus minus root over of b square minus 4ac. So you can see that the value of x are minus b plus minus root under b square minus 4ac by 2a. So if we take plus, then x equals to we will get x minus b plus root over of b square minus 4ac by 2a. If you take minus, we will get x equals to minus b minus root over of b square minus 4ac by 2a. So these are the root of a quadratic equation in the form ax square plus bx plus c equals to 0. So you don't need to do a lot of things. If any quadratic equation is given to you, maybe that will be 2x square plus 5x minus 6 equals to 0. So you know that instead of a, here is 2, right? So we can write down a equals to 2. We can write down b equals to 5 because the coefficient of x is 5. We can write down c equals to minus 6, right? The coefficient of the constant term is minus 6. So instead of finding arbitrarily what will be the root of the equation, we can put abc at here and we will get a root. Instead of putting anything, we can put here, we will get a root. So this is actually the general process of finding a root. You can use this particular expression for which you will get the root of an equation. This is a very interesting formula, right? Okay, let us move to the next slide, which is called the sum and products of a quadratic equation, roots of a quadratic equation. So you know, right, suppose a quadratic equation ax square plus bx plus c equals to 0 is given to you, then obviously you know that the degree of this quadratic equation will be 2. So definitely roots will be 2. There are two roots exist. So let me take these two roots as alpha comma beta. Then you can see that sum and products of root of a equation, but sometimes it is called relation between roots and coefficients, right? So what is relation between roots and coefficients? If we take alpha comma beta are the roots, then sum of the roots will be alpha plus beta, right? And product of the roots will be alpha into beta. So sum of the roots alpha plus beta will be minus b by a, right? Minus b by a, and the product of the roots will be c by a. So this is the formula of sum of the roots of a quadratic equation. This is the formula of product of the roots of a quadratic equation. Suppose an equation given to you which is 2x square minus 5x plus 6 equals to 0. So can you tell me, suppose if alpha comma beta are the roots of this equation, then can you tell me what will be the sum of the roots? It will be alpha plus beta, which is equals to definitely minus of minus 5 and by 2, right, upon 2. So it will become 5 by 2. So sum of the roots will be 5 by 2. And what will be the product of the roots? It will be 6 by 2, which is 3, right? So sum of the roots will be 5 by 2 and the product of the roots will be 3. So this is basically a relation between roots and coefficients, or you can say sum and product of the roots of the equation. Okay, let me discuss another topic which is formula for the discriminant. Okay, so what is formula for the discriminant? The discriminant of a quadratic equation is a function of its coefficient and represented by capital D or delta. It shows the nature of the roots of any quadratic equations where ABC are the rational numbers. Okay, wait a second, I understand that this particular definition you may feel very disappointment, or you may feel very annoying situation that this particular definition would feel like very difficult. Okay, so first of all, let me write down the Sridhar Acharya's formula, which is x equals to minus b plus minus root over of b square minus 4ac by 2a. So discriminant of a quadratic equation is actually this part, which is b square minus 4ac, right? So discriminant, which can be written down as d or capital delta, which is equals to only b square minus 4ac. This is actually the realization of what is discriminant of a quadratic equation. So instead of b square minus 4ac, we can write down capital D. So it will be minus b plus minus root under d by 2a, right? So this d is called a discriminant. Through this discriminant we will be understand that whether roots of a quadratic equation will be real or complex, right? So we'll discuss later on. So this is actually the discriminant formula, which is b square minus 4ac. Okay, so what is properties of discriminant, right? So okay, wait a second. Wait a second. Okay, let me just manage these things. What is properties of discriminant? Properties of discriminant says that we know, right, d equals to b square minus 4ac, right? So properties of discriminant says if the discriminant of a quadratic equation is greater than or equals to 0, right? If the discriminant is greater than or equals to 0, I mean non-negative, right? Non-negative, then the roots are real. If the discriminant is less than 0, I mean negative, right? Or you can say non-positive, or this is only negative, then the roots will be complex, right? So if d is greater than or equals to 0, then the roots will be real. If d is less than 0, then the roots will be complex. Okay, let me discuss again. X equals to minus b plus minus root under of b square minus 4ac by 2a. So here you can write down this as minus b plus minus root d by, okay, sorry for yeah. So the total part, which is x equals to minus b plus minus root under d by 2a. So if d is greater than or equals to 0, then definitely this root under d will be a real number, right? So and this b is also real and this 2a is also real, then definitely we will get x as real, right? Real numbers, right? If d is less than 0, so under root of d will be a complex number. Is that right or not? It is right, right? If d is less than 0, then under root of d is a complex number. Then obviously, since this is a complex number, we will get x as a complex number, right? So that is actually trying to say if d is greater than or equals to 0, then roots will be belongs to real number. If d is less than 0, then roots will be belongs to the complex number. One thing let me clear is if d equals to 0, which is the case of this, right? One of the case of d greater than or equals to 0, because here you can see the equal symbol is there, then x equals to will be minus b plus minus under root of 0 by 2a. So we will get minus b by 2a, right? So x equals to, we will get two roots definitely. One is minus b by 2a, another is same as minus b by 2a. So here you can see for d equals to 0, that is the discriminant. If the discriminant is 0, then we will get exactly two roots which are same, right? Okay, so you can understand that if d greater than or equals to 0, then the roots will be real. If d is less than 0, then the roots will be complex. Okay, so let's do some problems related to these topics so that you can actually shape your mind that how we can solve some examples, right, related to this topic, right? So wait a second. Yeah, so if alpha and beta are the roots of the equation, which is x square plus px plus q equals to 0, then the value of alpha square by beta plus beta square by alpha is, okay. So first of all, here the equation is given, which is x square plus px plus q equals to 0, right? So since alpha and beta are the roots of this equation, so by relation, here I can write down REL to the power n, relation between roots and coefficients. We can say that alpha plus beta will be minus b by a. Here you can see that b, instead of b here p is there, and instead of a here is 1, so you can write down as minus p by 1. So alpha plus beta will be minus p, and what will be the product? Product will be q by 1, right, c by a. So alpha into beta will be q, so we will get product of roots is q and sum of roots is p. So here the part is given, we have to find out the value of alpha square by beta plus beta square by alpha. So we will get, we can write down alpha square by beta plus beta square by alpha. So we can express this as alpha beta, so it will get alpha q plus beta q. What we are just trying to make this part in the part of alpha plus beta and alpha beta, because we have the values, right, alpha plus beta and alpha beta. So we can write down this alpha cube plus beta cube as alpha plus beta into alpha square minus alpha beta plus beta square, right. We know the formula, which is a cube plus b cube is nothing but a plus b into a square minus ab plus b square, right. So alpha plus beta and alpha beta, we have the values, we'll put later on. So we are just write down alpha plus beta and alpha beta separately, and we have alpha square minus alpha beta plus beta square. So we are just taking alpha square plus beta square on the left side, and that alpha beta, because we know the value of alpha beta, on the right side. So we can write down this part as alpha plus beta ka whole square minus 2 alpha beta minus alpha beta, we know, right, a square plus b square can be written as a plus b ka whole square minus 2ab. Okay, so you can see that alpha plus beta by alpha beta into this part is alpha plus beta ka whole square minus, there are 3 alpha beta is given, right. Okay, so let me erase something part, because I need some space to write down all these things. Okay, yeah, okay. So from there you can see that we can put the values, right. Here alpha plus beta will be minus p, right. So we can put minus p by q into minus p ka whole square minus 3q, right, 3q. So we will have minus p by q, and this will be p square minus 3q, right. So you can multiply this minus, and we will get p by q into 3q minus p square, right. So let me check which example is the correct example. So here you can see that the a, which option is the correct option? A option is the correct option, because p by q is there, p by q is there, 3q minus p square is there, 3q minus p square is there. So the first option is the correct option, right. Okay, so let's move to the next question, which is, if CD are the roots of the equation, right, then the roots of the equation these are, right. So first of all, first equation is given to us, which is x minus a into x minus b minus k equals to 0. Since it is not looks like the general equation of a quadratic equation, so we have to multiply these things and making this particular equation in the good looking form of a quadratic equation. So it will be, you can multiply this as x square minus bx minus ax plus ab minus k equals to 0, right. So x square minus, we can write down a plus bx plus ab minus k equals to 0, right. So if here you can see that CD are the roots of this equation. Since CD are the roots of this equation, so CD definitely roots of this equation. So by relation between roots and coefficients, we can write down c plus d as minus of minus a plus b by 1, which will be a plus b, right, and CD will be ab minus k, right, ab minus k, right. So here you can see, so then the roots of this equation are, so first of all we have to write down again that equation, x minus c into x minus d plus k equals to 0. So when we solve this equation, we will get x square minus c plus d x plus c plus d plus k equals to 0. So suppose roots of these equations are alpha comma beta, then by sum of the roots alpha plus beta we will get minus of minus c plus d by 1, which will be c plus d, right? And by c plus d you can say that c plus d is equals to a plus b, right? So what we will get, alpha plus beta as c plus d, right? Sorry, a plus b, yeah, a plus b, okay. And what will be the product of the roots? Product of the roots will be cd plus k by 1, right? So it will be cd plus k only. So here you can see the value of cd is ab minus k, so we can write down cd as ab minus k plus k, and after cancelling this part we will get ab, right? So the value of alpha beta will be ab, yes or not? So product of the roots will be ab and sum of the roots will be a plus b. So we can say one root is a and another root is b, because here you can see, right, from these two relation we can say that one root is a, another root is b. So the option number D will be the correct option, right? So this is all about this lecture, and we'll discuss more in the later lectures. So still you have till you have to solve these three examples which I will show you in this particular video at your home. You have to try to solve by your own at your home. After that we'll discuss in the later lectures. So that is all about this lecture, and thank you for joining this lecture. And yeah, you can see the photos, you can see the photos in this video of this homework, and you can do by your own, okay? Yeah, there are 4 questions are there, right? So thank you for attending this lecture, and keep trying, keep motivated and doing something for your life, and also do lots of maths, because through which you will understand what is the beauty of mathematics and how we can solve, how we can understand the nature of mathematics, right? So thank you for attending this lecture. We'll meet soon, okay? Yeah, thank you.